You see the headlines every single day, right? A new diet is linked to better health, or some specific habit is linked to success. But what if that link isn't quite what it seems? Today, we're going to dive into one of the most important ideas for just understanding the world, the huge difference between correlation and causation. All right, to get started, let's put on our detective hats. We're about to investigate a really bizarre statistical mystery, a connection so strange it almost sounds made up. I know, it sounds like the beginning of a terrible joke, doesn't it? But believe it or not, these two things are actually statistically linked. So what's the deal? Does eating a scoop of your favorite ice cream somehow, I don't know, summon a shark? And here's the wild part. The data is undeniable. When you look at a graph, as the sales of ice cream climb, the number of shark attacks also climbs. It's a really clear pattern. Now, our brains are wired to see a pattern like that and just assume one thing causes the other, and that, right there, is the trap. So, to solve this mystery, we've got to examine the evidence. And our number one clue is the statistical concept that connects these two totally unrelated events. We have to understand what correlation really is. Okay, so in plain English, correlation just means two things have some kind of statistical relationship. They move in sync. Like we saw, when ice cream sales change, shark attacks tend to change in the same direction. But it is so important to remember that the word relationship can mean a lot of different things.
First up is the one that makes the most sense to us, a positive correlation. As one thing increases, the other thing tends to increase too. You can think of it as a more relationship. The more hours you study, the higher your exam score is likely to be. Makes sense.
And of course, it can go the other way. This is a negative correlation. It's when one thing goes up, the other tends to go down. This is a more or less situation. A perfect example is a used car. The more miles you see on the odometer, the lower its price is going to be. And then sometimes, there's just nothing. The data points are just a random cloud all over the place with no clear pattern at all. This is no correlation. I mean, for adults, there's no reason to think your IQ would go up or down depending on your shoe size, right? The two are just completely unrelated. Now, looking at a graph gives you a pretty good gut feeling. But, statisticians like to be precise, so they use a single number to measure this relationship. It's called the correlation coefficient, and you'll usually just see it as the letter R. It's a really powerful little tool that tells you the strength and the direction of the connection. So here's how that R value works. It's a scale that goes from -1 to +1. A perfect positive correlation is a +1. A perfect negative correlation is a -1. And a big old 0 means there's no linear relationship whatsoever. So for our ice cream and shark data, we'd probably see a pretty high positive R value, maybe like a +0.8, showing that strong connection. Okay, so we found our big clue, a strong positive correlation. But now we come to the single most important rule in this entire thing. This is the one idea that separates clear thinking from some really dangerous assumptions. Let's just let that sit there for a second. Correlation does not imply causation. Just because two things move together does not mean that one causes the other. This is the golden rule. It's the master key to unlocking our whole mystery and just thinking critically about data in general. So if correlation isn't the cause, then what the heck is going on? Well, it's time to unmask the real culprits that are hiding behind the data. And in most of these cases, there are two usual suspects. The most common culprit by far is this hidden character in our story, a third or confounding variable. This is some other factor that's lurking in the background, pulling the strings on both of the things you're looking at, which creates this illusion of a direct link. And there it is, the solution to our fishy mystery. The hidden third variable is the weather. Hot temperatures cause more people to buy ice cream. And hot temperatures also cause way more people to go to the beach and swim in the ocean. And that just increases the chances of a shark encounter. Ice cream isn't causing shark attacks, the hot weather is causing both. Let's try another one. The data clearly shows a strong positive correlation between a child's foot length and their reading ability. So what? Do bigger feet make you a better reader, or maybe reading a lot makes your feet grow? It sounds absolutely ridiculous, right? Of course not. Once again, there's a third variable doing all the work behind the scenes: age. As kids get older, their feet naturally get bigger. And with more time in school, their reading ability gets better.
Age is the confounding variable that's causing both things to increase together.
Okay, on to our second usual suspect, the directionality problem. This one is a little different. It's when two things might actually be causally linked, but the correlation doesn't tell us which way the street goes. Is A causing B, or is B causing A? Think about the known correlation between low vitamin D levels and depression. It's a real head scratcher. Is it that a lack of vitamin D actually contributes to causing depression? Or could it be that being depressed causes people to stay inside more, away from the sun, which then leads to lower vitamin D? The correlation alone can't tell us. Both seem plausible. So we've unmasked the culprits behind all this faulty logic. Now let's turn this knowledge into a skill you can actually use. How can you spot these misleading connections out there in the real world? The key is just knowing what you're looking for. This big mistake, mixing up correlation with causation, actually has a name. It's called the false cause fallacy. And once you know what it is, I promise, you're going to start seeing it absolutely everywhere. And why does this matter so much? Because this fallacy is a really powerful tool of persuasion. You see it constantly in news headlines that are desperate for clicks, in sales pitches making big promises, or by politicians trying to link their policies to good news. The big takeaway here? Always be a little skeptical. So here it is, your simple, powerful toolkit. From now on, whenever you hear a claim that A is linked to B, just stop and ask yourself these two questions. First, could there be some hidden thing C that's causing both? And second, could the cause and effect actually be the other way around? This simple little mental check will make you a much, much sharper thinker. You're now equipped to spot the difference between a simple connection and a real cause and effect relationship. But we've really only just scratched the surface. That R value we talked about, it only measures straight line relationships. So what happens when the connection is real, but it's a curve instead of a line? The world of data is just full of these fascinating patterns, and knowing the difference between correlation and causation is your first and most powerful step to truly understanding them.